Hello, my name is Paolo Taddei. I'm the founder of SPIKE Renewables. SPIKE Renewables is an engineering company based in Florence, Italy. And in this project, in GEOFLEXheat, we have a role of designing and also the construction of the scaling reactor for the installation in Italian site. The scaling reactor, the Italian demo site, will act as a system that will reduce the silica content inside the brine of the geothermal fluid. So this is a quite important activity because every time that you have a brine that you want to reinject in the geothermal well, you need to have this brine at high temperature because when the brine has a high content of silica, if you reduce the temperature, then you have a oversaturation of silica. And this may cause some scaling in piping, in valves, in all mechanical stuff. So it's very important to reduce the silica content inside the brine, so that you are able to reduce also the temperature, and from the overall efficiency of the system, it's much better to give back the brine at low temperature. So the scaling reactor in the Italian demo site will reduce the silica content and collect the silica in a way that we can reuse it. And so has two main purposes: reduction of silica for brine reinjection at low temperature, and collection of silica and mineral to have, let's say, second utilization of these minerals. Yes, this system will prevent silica scaling because the reduction of the percentage of the silica inside the brine will lower the saturation level. So when you have silica dissolved in a brine at a high temperature, you don't have silica scaling because you are over the line of the saturation. So when you reduce the temperature, you are oversaturated, and so silica start to scale and in mechanical components. So you are not able anymore to inject the brine at low temperature in the well. So this system will prevent the silica scaling by removing the silica content inside the brine. The collection system is a part of the reactor because in this case, in the Italian demo case, we will have a reactor that is shaped as a tank, but also is a shape of cyclone. So it has two main purposes. The first one is to have a retention time sufficient for a reaction to have time to reduce the silica, and the other purpose is to have a shape of a cyclone so that it acts as a filter. So we are expecting that the collection of mineral are on the bottom of this reactor, and we will collect it by opening and closing a valve, so in a batch mode. And this is important because this mineral can have a value. So silica can be, let's say, sell and have a value in a different kind of market. Yes, this is, I would say, the first time that this kind of system, reduction of silica by lime injection. Lime is a solution of calcium hydroxide. We know that from literature and from studies that have been performed so far that this system is expected to be very effective because the speed of the silica reduction is very, very fast in respect to other systems that do not inject any chemicals. So the challenges are to verify the actual injection of lime in a real case. So the other challenge is that when you have some experiments made in labs, you use different kind of brine, but each system, each plant has a different composition of brine. So I would say that you have to tune every time the system to the specific location. And that's what we are going to do, because this system is full equipped of instrumentation of, let's say, temperature, pressure, pH, but also composition of mineral inside the fluid. So we are able, with all this instrumentation, to modify and adjust the amount of lime that we will inject. So yeah, I think it's the first time that this application of lime injection is made in a real case, in a real industrial plant. I would say we can split in two different opportunities. The first one, the most important, is the possibility to take from the geothermal fluid more energy. So the overall efficiency of the plant will increase. And when you have a high amount of flow rate of brine to be reinjected, if you have a different temperature of 10, 20 or 40 degree, you can imagine the amount of power that you can take out from the brine. So this power has a direct value that is quite easy to quantify. The other let's say benefit could be also the mineral collection. The mineral could have a value on other kind of markets.